Hello there, algebra friends. Welcome to 10.2.6. Which method is best? Kind of think of this as a greatest hits of some of the equations we have been solving this year. This is going to be our last actual lesson of the school year, so you should feel very proud of yourself for making it to this point. Next week, we will have a review available for you Tuesday, Wednesday, and then we'll be taking our last summative of the year on Thursday and Friday. So, wow, we've made it. Before we jump in and do some solving here, folks, since it is our last lesson together, I want you to tell me at the top of your paper, what has been something you'll always remember from your algebra class? Maybe a memory you have, maybe a buddy in class that you miss, maybe you miss a teacher in class, but tell me at the top of your paper. I'd love to read through these. I will just say I loved starting my morning with algebra. So my morning algebra classes, so many fun and funny and kind students that would just make me laugh in the morning. It was just such a great way to start my day. So thank you, periods 1 and 2. You guys are the greatest. This is my little heart. So thank you guys. Be sure to share something up top, and then we will get started here. So we are going to be solving all types of different equations here, folks. This is all equations we have seen before. So let's use all of our strategies, all of our thinking patterns, and let's get rocking and rolling here, folks. Letter A, let's see, what kind of a problem is this? This is an absolute value problem. So if you remember, folks, this an absolute value makes whatever's inside positive. So the absolute value of 8 would give me 8, and the absolute value of -8 would also give me an output of 8. So that means my input, my little, this little inside part, this little 4x plus 20, that can either equal +8 or it can equal -8. Right? So that inside can be a positive or a -8. Oops, I forgot to set that equal to 8. And now we're just going to be solving these equations, all right? So I'm going to start by subtracting 20 from both sides. 8 minus 20 gives me a -12. Dividing both sides by 4 gives me an answer of -3. Now I can solve this one. Start by subtracting 20. -8 minus 20. That's going to give me a -28. Dividing both sides by 4, I get -7 for my second answer. Now, it is always a good idea to check your answers. And that just means I'm going to plug in -3 and make sure I get something that makes sense. And it looks like I get 8, and I know the absolute value of 8 is 8, so we're ready to rock and roll. Then I'm going to plug in -7 and make sure I get something that makes sense. And it does. So always a good habit to check your answer. You also could plug that into Desmos and make sure you get something that makes sense, all right? Let's move on to letter B. Letter B is a quadratic. So absolute value, quadratics, your mind should right away jump to the possibility of having 2 solutions. Not always having 2 solutions, but the possibility. Alrighty? So the solving strategy I like to use for when I have a little quantity squared like this situation is I like to get that, solve for this by itself. So I'm going to box that, kind of that question mark. That's the box that, the variable is a part of, the chunk That's the word I was looking for, the variable chunk. You want to isolate that variable chunk. So I'm going to add 6 to both sides, and then I'm going to use the look inside strategy. So if I want something squared to equal 36, I've got 2 options, either 6 times 6 or -6 times -6. So that means x minus 13 either must equal 6 or it must equal a -6. All right, because this chunk either has to be a +6 or a -6. And then once I get to this step, I just got to solve these 2 little baby equations here. 6 plus 13, that would give me 19, right? And then -6 plus 13 would give me 7, +7, right? And always a good, even I forget this sometimes, folks, but it's always a good habit to get in is checking your work. So 19 minus 13, that would give me a +6 squared, which is 36. And then 7 minus 13, that would give me -6 squared, which is 36. Okay, so even if you can kind of just think it through and make sure it checks out, that is awesome mathematic behavior. All right, mathematic behavior. What does that even mean? I just made that up on the fly. All right, here's my chunk this time. So my letter A was an absolute value. Letter B was a quadratic. This is a square root. So remember, we can't square root a negative number. That's what my chunk is this time. I'm going to start by getting rid of that 2. So I'm going to just divide both sides by 2, and I'm going to get that equation there. I'm going to use the undo strategy. So what's the opposite of a square root? That's going to be a square. So I'm going to square both sides. That's going to cancel out, and I get x minus 4 equals 7 times 7, which is 49. Add 4 to both sides, and I get x equals 53. We're being excellent mathematicians since it's our last day together, and I'm going to just plug in 53 and make sure it checks out. And it does. All right. Good stuff. So we had those types of problems. The next one, this is actually a cube, right? We are taking x plus 1 to the 3rd power. So this is a cube. So my chunk here is x plus 1. What does x plus 1 have to equal? What number times what number times what number is 8? If you don't know that off the top of your head, we could do the undo method. The undo of a cube is a cube root. So that's going to be hiding in the math folder. Scroll down to the 4th option. The cube root of 8 is 2, and maybe some of you could do that in your head, right? 2 times 2 times 2 is 8. So that means I need x plus 1 to equal 2, right? That's the chunk. That's what I need to be 2. So when I do it 3 times, it equals 8. So then what does that make x? X would equal 1. And let's check our answer here by plugging in 1 for x. 1 plus 1 is 2. 2 cubed is 2 times 2 times 2, and that equals 8. So I know I'm rocking and rolling here. This next problem, letter E, this is another quadratic, right? You see that squared up there? So I'm first going to highlight my chunk. I'm going to highlight what's in parentheses there, and I'm going to isolate it. So I'm going to get rid of that multiplying by 3. I like to isolate my chunk, divide both sides by 3, and I get x plus 12 squared equals 9. Lots of different strategies you can use here, but I like the chunking or the look inside strategy. What number squared equals 9? So that's going to be 3 times 3 or negative 3 times negative 3. Now you might ask yourself, why didn't I have that over here with the cube? But see what happens when I do negative 2 times negative 2 times negative 2? Negative 2 times negative 2 is 4, and 4 times negative 2 is negative 8. So that doesn't work. So only quadratics are going to have those two solutions where you have to think of the positive and the negative. Alrighty, so the chunk can either equal 3 or it can equal negative 3. So then I'm just going to solve these guys. 3 minus 12, that gives me negative 9. Negative 3 minus 12, that would give me negative 15, I believe. And let's check our answers here. I'm just going to plug each of those into my chunk. I bet a lot of you are like, stop saying chunk. Okay, I won't say it again. And that worked out. All right, so always do what's in parentheses first. Gotta remember PEMDAS, folks. PEMDAS. Parentheses comes first, and I get 9 in both of those. Alrighty, folkaroos, we've got our last problem here today. This looks like I've got some fraction. I gotta bust those fractions up. How do I get rid of those denominators? Nobody likes fractions, except for I actually do. So I've got 4 in the denominator. So I've got x and 11 being divided by 4. What's the opposite of dividing by 4? Multiplying by 4. So I'm going to multiply every term by 4. These cancel out, and I'm left with x plus 11 equals 4 times 5, which is 20. Subtracting 11 from both sides, I get x equaling 9. Let's make sure this works, especially when we're fraction busting, because it can be easy to make a mistake. So I'm just going to plug in 9 into my original equation. And if you don't like fractions, we can use our calculadorias here. So I've got 9 fourths plus 11 fourths. And what do you know, folkaroos? That equals 5. Alrighty. Shinners signing off. Thank you for a lovely school year. Please email me, schedule a Zoom. I would love to see you and check in with you. But thanks for popping in, and let me know if you have any questions. Have a fabulous day.